Hey y'all, we are working on notes 31 and today we're going to be matching function and graphs. So they give us functions that look like this. This is what we know as the standard form of this graph. And the first thing we're going to think about is A. So if A is positive, we know this already, the graph looks like a cup, right, or a smile. And then if A is negative, then the graph looks like a frown, like we're going down like a frown. So those are two things you already know. But you might have decided or realized over the course of the last couple weeks that if A is a big number, then the graph looks like this, and it looks really skinny, right? It's a skinny graph. And then you might have noticed too, if it's a small number like the number 1 or a fraction, right, 1/2 or 1/3, then you start to see the graph kind of open up like this and get a little wider. So that's how A affects our graph. We also know that we have the letter C. And the letter C is the constant. If we're thinking about it with ax squared plus bx plus c, it's the number that's all by itself. So it's called a constant. And it's always the y-intercept. Some of you guys will remember that from before, which on a graph is wherever the line touches the y-axis here. So that would be the y-intercept right here. So if a function has no c, so if it's like 2x squared plus 2x, and there's no c, then it's going to go right through the origin, just like that. So its y-intercept will be there at the origin. We also have seen something that looks like this. So in this section, it's called the factored form because we see the factors. Right, remember that each of those pieces is called the factors. So I can use it to find the solutions, which on the graph, of course, we know are wherever it touches the x-axis. Right, so here are where I find my solutions or my roots or my zeros. So if I'm looking at this function here, it would have solutions at this section, -3, and from this factor 4. X plus 2 squared, the second one here, would have solutions at -2 and -2, right? There's 2 of them, so we would know that it's going to bounce at -2. So it's going to hit here, and it's going to bounce back up, rather than crossing and going all the way through like we see in this graph there. So that's our factored form. So we had our standard form, which is this one here, and then we had our factored form, which was this one here, and then we also have one more form, and this form is called the vertex form. That's this one right here. So this is the vertex form, or format. It's just another way of writing the equation, and it's called that because it gives me the vertex. Which on the graph is where it turns around. So either it's minimum, if it looks like this, or if you have a different graph that looks like this, it would be the maximum. That's our vertex. And the x is the opposite number. So just like when I'm finding solutions, but the y is the same. Right, so if the equation right in here, I'm going to look at my x right here. I see that it's +4. So the vertex would be at -4 because my x is opposite. And then the y is the same. This one right here is my y. So I would know that the vertex of this one is at -4, 9. So I'd say, okay, I'm going to go over -4 and up 9. And I know that that is where my graph is going to start. That'll be the center of it. So just a couple of practices here. If I look here, I see, okay, this is -3. So we would turn that into +3 because x is opposite. Well, then 6 is the y, just regular 6, no changing. Y is the same. So here I see x plus 2. I'm going to switch that to negative 2, and then the plus 10 would stay the same there. So these are my vertexes. So putting it all together, we have all of these functions here are the same exact equation, right? So it says all are all the same function written in different form. So we have the vertex form first, we have the factored form, and we have the standard form. So for each of those, it tells us something different. So the vertex form, which is written again here, tells me the vertex. And it tells me that the vertex is at this one here, remember the opposite, negative 4, and then here, negative 4. So my vertex is at negative 4, 1, 2, 3, 4, and down 4, 1, 2, 3, 4. This is my vertex right there. I don't know yet if it's my maximum or my minimum, but I know that that's where it's going to change directions. So my factored form tells me the solutions. So for this one, I know that the solution would be x equals negative 2. And for this solution, x equals negative 6. So I can graph those at negative 2 and then negative 6. So I can start to see my parabola starting to take shape here. And then my standard form tells me two things. It tells me if I look at my A, it tells me that this is a regular graph, but that it's up like a cup, so it's concave up, which we can start to see here. It'll look like this. And then we also know that that 12, the C value, is our y-intercept. So I'm going to count up 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I'm just going to estimate 11 and 12. So I know somewhere up here is going to be the y-intercept. And then from there I can just graph my line here. I know it's going to go up that way and come up this way, just like that. I always know that this is probably going to be pretty close to this, right? If I'm starting to round it out that way. That looks kind of ugly, so I'm going to try one more time. Put points here and here, round it out, up like that. Always going all the way off and using my arrows to show that it goes forever. So if they give me the 3 equations, I can start to see what my graph looks like in a pretty good sketch. Today they are going to show you in your IXL, they're going to show you a few graphs and a few equations, and you're going to match them. So this is one of my favorite IXLs, so I'm happy to help you, and let me know if you have any questions. Thanks.